Now, a very important use of finding the gradient, or dy dx, is when we're finding what we call local maximums and local minimums. Local because it's a localized lowest point and a localized maximum. Now, the red line I put on is the tangent to the curve, which, if you're looking at the tangent to the curve, that will always be, at that particular point, will give you the gradient. If you can work out the gradient of the tangent, that's the red line. Now, specifically, when you've got a maximum point, the tangent to the curve is horizontal, it's flat, so it has zero gradient. Also, when you're looking at a minimum point, zero gradient. Because if you think you had a negative gradient turning to a positive gradient, the only way to get from negative to positive is to go through zero at some point. So being able to realise that the gradient is zero, a maximum and minimum point, will help us a lot in the next few videos. Let's take this particular graph. Where is a maximum or minimum point on this particular curve? Well, if we start off with the assumption that we're going to go dy dx to find out the gradient, that gives me 6x plus 12. If we're bearing in mind that we're looking for the point where the gradient is 0, that means it's a maximum or minimum point, we can say that the gradient dy dx is equal to 0. So 0 equals 6x plus 12. At that point we're just solving an equation. Luckily this one's a linear equation, so we've got negative 12 equals 6x. So x equals negative 12 divided by 6 is negative 2. So x is negative 2. Will be either a maximum or minimum point. Now at the moment we don't know what that is. Okay, so far we found out that the gradient is 0 when x was negative 2. We also found out the gradient dy dx was 6x plus 12. So we're now looking at the point, the graph is flat at x is negative 2. I'm now going to look either side of negative 2, negative 1 and negative 3. If I substitute negative 3 into my formula for the gradient, I get negative 18 plus 12, which is negative 6. The negative part is important. So that means my graph at negative 3 was going downwards. And then it's flatlining. If I now look at the point negative 1, so I don't need that previous information, 6 times negative 1 is negative 6, add 12 is positive 6. I've got a positive gradient at 1. And as you can see from my picture, that's given me a minimum point on the curve. So I can say now that I know that the graph of y equals 3x squared plus 12x has a minimum point at x equals negative 2. Your challenge is to find out what we call a stationary point, either a maximum or minimum point, for y equals negative 2x squared plus 10x. So you have to not only find out where the gradient is 0, but tell me, is it a maximum or minimum point? Have a go at that, press pause now and come back with your answer. So hopefully your solution looks something like this. When I differentiate it, dy dx equals minus 4x plus 10. I'm trying to find out where the gradient is 0. It's called a stationary point. So I'm going to set my gradient to be equal to 0. dy dx is the gradient, don't forget. So 0 equals minus 4x plus 10. Simple equation. 4x equals 10, x equals 2.5. Important information. So I'm going to start my drawing. I know that it's flat at 2.5. So I'm going to look either side of that. I'm going to make life simple for myself. I'm going to look at 3, and the other way I'm going to look at 2. So I'm going to substitute the number 2 into my equation, my formula for dy dx. So if I substitute 2 into here, I get minus 4 times 2 is minus 8, plus 10 is positive 2. So positive 2. Positive means it's going up. So now I'm going to look at 3. Substitute 3 into negative 4x plus 10. Well, minus 4 times 3 is minus 12. Add 10 is negative 2. So I've got a negative gradient. So negative, so it's going downwards at that point. Clearly, that's a maximum turning point or stationary point.